Section 3.5 is parallel and perpendicular lines. So the goal in this section is we want to learn about the slopes of parallel lines and the slopes of perpendicular lines, and then we're going to look at graphs of equations still. Okay? So, two non-vertical, they're not vertical, that's important. Two non-vertical lines with slopes M1 and M2 are parallel if and only if M1 equals M2. If we have two non-vertical lines with slopes M sub 1 and M sub 2, the two lines are parallel if and only if their slopes are the same. That's what this says. Parallel lines have the same slope. That's what you get from this. If you need to write it down, write it down. Parallel lines have the same slope. So note, two vertical lines with an undefined slope or with undefined slopes are always parallel to each other. Okay? So, in example 1, we want to find the equation in what form? Slope-intercept. In slope-intercept form for the line that's parallel to the given line and passing through the indicated point. Curb your enthusiasm just a little bit. So, we want to find the equation in slope-intercept form for the line parallel to the given line. This is the given line here. And passes through this point. So, if we want it parallel to this line, what should we do with this line first?
Put it in slope-intercept.
Put it in slope-intercept form to find what? The slope. Good. So let's do that. Okay. So we have 6x plus 2y equals 19. Our goal is to solve this for y first so we can identify our slope. So what do we do first? Subtract 6x from both sides to get 2y equals negative 6x plus 19. Are we done?
No.
No, because we have to do what to both sides?
Divide by 2.
Good. Divide by 2 then. And so we get y equals what?
Negative 6x.
Nope.
Negative 3. Negative 3x plus 19 over 2.
You got it. All of this work to say what?
The slope is negative 3 over 1.
Good. Or you can write just negative 3, either one. You can write negative 3 over 1 or you can write negative 3. Whatever makes you happy. So you get your slope is negative 3. That's what we did. Why is that helpful? Because now what we want to do, you can't read that. We want to use point slope form. Good. We now want to use point slope form. Why do we want to use point slope form? Because some people are saying why.
We already have the slope and we have a point.
Wait a minute. Let one person explain it. We already have what?
The slope.
We have our slope and we already have our what?
Point.
What is your point?
Negative 6, negative 3.
Very good, all of you.
Wait, so are you still going to end up in slope-intercept form?
You're going to have to solve that next one by putting it in slope-intercept form.
Why don't we put the point, you have a point in the slope. Why don't we put the point in the slope-intercept form and find a b?
Because, that's a good question. So the question was, why don't we take the point and the slope and put it in slope-intercept form? Because slope-intercept form only works when you have a slope and you have what? A y-intercept.
So you can put it into the solve for b?
Well, actually, yes, you can do that. So if you want to. So her question is different. And the answer is yes, you can do that. Because she's saying, can we take our slope and can we take our point and put that into slope-intercept form to find our b first and then go back and put it in slope-intercept form? You can absolutely do it that way.
Is that more work or less work?
No, it's fine. It's about the same. Either way is fine. If you want to approach it that way, I'm perfectly fine with that. You do not have to do it this specific way. This is just a way I'm showing you to apply the other concepts that you've learned. If you want to take your slope in your point, put that in slope-intercept form to actually find out what your y-intercept is going to be, go ahead and do that. Because then you can take that y-intercept and then you can take your slope and put that in slope-intercept form and you'll be done. That's fine. Go ahead and do it that way. You'll get the same exact thing that we're going to get whenever we work it this way. What other questions do you have? Very good. Okay, so you now have your slope. You have a point. You can use point slope form or you can use the method that we just discussed. Okay, so if you choose to use point slope form, remember that point slope form was y minus y1 equals m times the quantity x minus x1, and we're thinking of this point here as x1 comma y1. Use a different color. x1 comma y1. So here you would put minus 13, and over here you'd have minus 6. That's not multiplying. That's just us thinking about these, and we're going to write out our steps. So we have y minus negative 13 equals what? Negative 3, good, times the quantity x minus negative 6. And again, if you choose the other method, just watch, you'll get the same thing. Okay, so this becomes y plus 13 equals negative 3 times the quantity x plus 6. Now distribute the negative 3 on the right side, and we get y plus 13 equals negative 3x minus 18. Now we do what to both sides? Subtract 13 to get y equals negative 3x minus what? 31. And that's it. It's the same exact thing. It should be. It better be. Good. Very good. Very good. And some people prefer that, the way that you described. Some people prefer that way, and I'm perfectly fine with that. Questions? Okay. Note, we can also use the knowledge that parallel lines have the same slope to answer questions that are more geometric in nature. So each set of 4 ordered pairs defines the vertices in counterclockwise order of a quadrilateral. What do we mean by counterclockwise?
That's count as negative, right?
So each set of 4 ordered pairs defines the vertices in counterclockwise order of a quadrilateral. Determine if the quadrilateral is a parallelogram. What in the heck? A parallelogram is a quadrilateral in which both pairs of opposite sides are parallel, meaning they have the same slope. Okay? So this is just a matter of checking. Okay? So what we're going to do here is we're going to label our points. I'm going to label this one as A sub 1, A sub 2, A sub 3, A sub 4. Okay? Are we all right?
Yeah.
Okay. So now what you can do, if you want to, go ahead and plot those points, just so you can see what we're actually going to do. Go ahead and take a minute and plot those points, just to make the connection with what we're about to write out mathematically. We plotted our points. This is negative 1, 6. This is negative 4, 7. This was what point here?
Negative 2.
Let's label it. Negative 2, 3. And the other point was? 1, 1. Okay? So the question is, do we think this is going to be a parallelogram, right? Because the instructions tell us to determine if the quadrilateral, I can say it, is a parallelogram. So this would be a parallelogram if the pairs of opposite sides are parallel. So just so we are going with how we label them here, we have A1 here, A2 here, A3 here, and A4 there. So we need to check the slope of this line, using the points, right? And if the slopes are the same, then that means what? Then we have those lines are parallel, which means what in terms of our original question? It's a quadrilateral, but what it says determine if the quadrilateral is a what?
Parallelogram.
So if the slopes are the same, that means we have a parallelogram, not just parallel line. We have a parallelogram. Okay? So we have to check that. We have to check it. So we're going to find the slope of that one. Okay? So finding the slope of this one, you choose whatever you want to choose for that. We would then have 3. Do you want to choose those or do you want to choose the other? It really doesn't matter. You can choose. Oh, didn't mean to erase it. There we go. So here, you can choose these opposite sides like so, or you can choose these. Which ones do you want to choose? Which one?
The second choice.
The what?
The second choice.
The-
A1 to A4.
These?
Yeah.
This and this?
Yes.
Okay. So here, you have you can choose whichever one. 3 minus 7 over -2 minus -4. That will give us -4 over -2 plus 4, which is -4 over what? 2, good, which is what? -2, good. So then we need to find the slope of this one. So then we would have 1 minus 6 over what?
1 minus
So this gives us what? Over 2. Are those the same? No, they're not. Okay, the slopes. So the slopes of the two sides are different, which means the lines specifically are not parallel. So does the quadrilateral form, is that a parallelogram? No, this is not a parallelogram.
So you could use any 2 points on the graph, or you have to use two specific points.
So the question was, can you use any 2 points, or does it have to be specific ones? It has to be, you have to make sure you choose opposite sides. So either you choose these or those. Either you choose these lines or you choose those lines. Either, that's right. Okay. So let's look at another example. Yes?
Can you just look at the graph and you tell like the slope?
Your graph has to be 100% accurate in order to do that.
I was thinking like Rob over.
And you can think of it that way. So yes, you can look at it geometrically and do that, but your graph has to be accurate in terms of units. Your coordinate plane has to have your units appropriately placed. Versus like a sketch without that. You know what I mean? Okay. All right. So let's look at part B. Same instructions. Same instructions for part B. Okay. So we'll take a second. We'll plot our points. So -2, -3. Then we have -3, -6. Did you like labeling them like we did before? So we'll call this one A1, A2, A3, and A4. So that's A1, that's A2. A3 is 1 what? 1 -2. And then we have 2, 2, 1. I see it went out. So we'll call this A3 and that one A4. Okay? Do you want a couple minutes to try it?
Yes.
Okay, I'll give you a couple minutes to try it. Minutes and work on this. As we discussed though, if whenever you check one set of pairs and their slope is the same, that's good. Means that's those opposite sides are parallel, and then you have to check the other pair to make sure those are parallel too. Okay, so go ahead and take a couple minutes. Let's check to see what we have. Some are saying yes, it's a parallelogram. Some are saying no. So which pairs did you check first?
A1 and A4.
A1 and A4? So you did A1 and A4. So this is what? So would it help if I use a color?
Yes.
Yes.
A1, A4, that's what you want to check first. So what do we have? 1 minus -3 or 1 plus 3, either way, over what?
2 minus -2.
Good. So this is 1 plus 3 over 2 plus 2, which is what? 4 over 4, which is what? 1. Okay, and then you check
A2 and
A2, A3. So what do you have?
-2 minus -6 over 1 minus -3.
You get -2 plus 6 over 1 plus 3, which is what? 4 over 4, which is 1. So what do we get from these two lines?
They're parallel.
They're parallel. So these are parallel. So far, so good. And then we have to check
A1 and A2.
A1, A2. So let's check it. What do you have?
Is -6 minus -3. Okay, -3.
And or divided by?
Divided by -3 minus -6.
Okay, so you get -6 plus 3 over -3 plus 2, which gives you what?
3 over 1, or just 3.
Gives you what?
3 over 1.
-3 over what?
-1.
Which is
3.
3. Okay, then we check. Yellow bad or good? Is yellow bad or good?
No, that's good.
Okay, so then you have what?
1 minus -2.
Over 2 minus 1 to get 1 plus 2 over 1, which is 3 over 1, which is the same thing as 3. So what do we get here? They're parallel. So how do we answer our question? The lines are parallel. So we have, yes, this is a parallelogram. Good. So yes, This is a parallelogram. Excellent. What questions do you have here?
You have to check off 4.
You have to check those pairs. You would have to check the pairs.
So you have 4 answers. Well, like 1.
You'd have 4 slopes appearing, and your goal is to check to see if the opposite sides are parallel. Do you have to check? Yes, if it's asked, is this a parallelogram? Yes, you have to check. What other questions do you have?
I have a question. So, you know how it's like y2 minus y1 over x minus x. So for like the second one in yellow, if you would have did like -2 minus 1, will you still get like the same answer like how you did at the end?
As long as you are consistent.
Okay.
Yes. What other questions do you have? Okay. We talked about parallel lines. What's left? Perpendicular lines. Perpendicular lines. And y'all look like y'all having a moment, so pack up and have a good weekend. So the theorem says the following. Suppose M1 and M2 represent the slopes of 2 lines, neither of which is vertical. Okay? The 2 lines are perpendicular. The 2 lines are perpendicular. If and only if M1 equals -1 over M sub 2, or equivalently, M sub 2 equals -1 over M sub 1, and M1 times M sub 2 equals -1. So another way of phrasing this, we have 2 lines are perpendicular if we know their slopes are negative opposite reciprocals. Okay? So the note here, if one of 2 perpendicular lines is vertical, the other is horizontal, and their slopes are respectively undefined and 0. So particularly an example here is just the XY coordinate plane, right? Questions here? Make sure you see me after class for attendance. Okay, so let's go through an example. We want to find the equation in example 3. We want to find the equation in slope-intercept form for the line perpendicular to the given line and passing through the indicated point. So I've given you this equation that represents a line, and I've given you the point 2, 5, and I want us to find an equation in slope-intercept form for the line that's perpendicular to this one that passes through this point. What do we have to do? Distribute. So what's the goal? What's the goal in distributing? I'm asking, what's the approach for the problem?
To simplify the equation on the left side.
So to simplify the equation on the left side, which Alexandria was saying we distribute, right? But for the goal being to do what?
Put it in point slope form.
To put this in point slope form?
To get x.
Not necessarily to really find what M is.
To find out what M is, right? Our goal is to find out what M is for this given line, right? Because if we find out what M is for this given line, if we want to find a line that's perpendicular to this line, then finding M will allow us to do what? Take the negative reciprocal of it. It'll come back on. Take the negative reciprocal of it, hopefully. Take the negative reciprocal of it, and then we will have the slope, and then we will also have what else that was given? The point, and you can either use point slope form or the method that you know using the slope intercept form. Is everybody good on the approach? Do you want to give it a try first?
Yes.
Okay, I'll give you 3 minutes to try this. Many of you have the initial step, which is the solving the first equation for y. So let's go ahead and do this. So the first thing you said we need to do is simplify the left-hand side, which means we have to distribute the 2, and we also have to distribute what? The -3, right? So let's do that. When we do that, we get what? Someone in the back row. all the way across.
Y,
Mm-hmm.
plus 2x minus, well, negative 3x
Minus 3x, you said it correctly the first time.
plus 3y
Plus 3y, good, equals,
negative 4.
good. Now what do we do? Someone on the second row all the way across from the back.
Combine like term.
Yes, combine like terms to get what?
5y minus x equals negative 9.
Equals -9. Good. What questions do you have so far? Okay, keep moving up. Third row all the way across. What do we do? Oh, I'm patient. Oh, I can't hear you.
Solve for y, right?
You solve for y, so what do we do?
You move negative x to the other side.
Yeah, to get what?
Take y equals
You get what? 5y, good.
-9
Uh-huh.
plus x, right?
Plus x, yeah. So x minus 9. Or, as you said, I know it went out. It'll come back up. So you get 5y equals x minus 9, or as you said, -9 plus x. Good. Okay, next row all the way across.
You divide by 5.
You divide by 5. Good. Divide by 5, right? To get what?
Y equals x over 5 minus 9 over 5.
Minus 9 over 5. And is this in the form that you wanted to be able to identify your slope?
No.
No, so what do you write it as?
Y equals negative 5 x minus 9 over 5.
No.
1/5.
Y equals 1/5. Good. Y equals 1/5 x minus 9/5. So at this point, all we're doing is rewriting it. We're not taking the opposite reciprocal of that slope yet, right? We just want to rewrite this so we can identify what the slope is. So here, x over 5 is the same thing as 1 over 5 times x, because there's an invisible 1 right here in front of x. Are we good here?
Yes.
What questions do you have?
So 1/5 is the slope, right?
Yes, so 1/5 is the slope. So all of that to say, we get m is equal to 1/5 here.
Okay. Can I get the other method, like when you do y2 minus y1? But I use the 2y. When you first distribute, that's the coordinates I use.
Okay,
It's
so
gonna work the other time.
you're working a little bit harder to get it. You're working a little bit harder to get it in that way because I didn't. So whenever you use m equals y sub 2 minus y sub 1 over x sub 2 minus x1, is that what you're using? Okay, so if you have 2 points, then ideally you want to use that to find your slope. But if you're given a line and you need to find the slope of that line, the ideal way is to solve this way. There are multiple approaches. What other questions do you have? Okay, so we did our first part of our approach that we discussed. We found our slope. And we found our slope so we can identify which slope is what? Perpendicular to it, right? So I'm going to use this symbol for perpendicular slope. I'm going to use that for perpendicular slope. So what is the perpendicular slope then? -5. Good. It's -5 because it's the opposite reciprocal. Okay? Are we good? Okay. So we found our perpendicular slope. Now we have our perpendicular slope and we have a what? Point. So we use point slope form. Okay? First row all the way across. Tell me what we write.
Y minus y.
Go ahead. Alexandria started. Go ahead.
Y minus 5 equals -5.
Y, hold on. Y minus 5 equals what?
-5, and then in the parentheses, x minus 2.
X minus 2. Good. Does everyone agree? Okay, let's reverse it. First row all the way across, going back. What do we do?
distribute the -5 on the right hand side.
Or what do we do with the left hand side?
You can move the 5.
Do we move it yet?
No.
So you said on the right side we distribute that -5, but do we just not write it down here? What do we do?
No, you just bring it down.
Oh, bring it down, right. So we get, go ahead.
1 minus 5
Mm-hmm.
equals -5x plus 10.
Plus 10. Good. Good. Second row all the way across. What do we do? What do we have?
Plus 5.
Plus 5?
Well, you add 5 to both.
Add 5 to both sides to get
Y equals -5x plus 15.
plus 15. Good. Do we do anything else?
No.
No, we're done, right? Because this is in what form? Slope-intercept form. So we found an equation in slope-intercept form for the line that's perpendicular to this given line passing through this point. That's what we found. What questions do you have? What questions do you have? You need a minute? I see some shaking heads no, some yes. I'll give you 30 seconds. Good. So there was a question. How do you graph this? This is in slope-intercept form. We know our y-intercept, as Lisa said, our y-intercept is 15, or as an ordered pair is what?
0, well,
What is it?
oh, 0, 15.
0, 15 is our y-intercept. Okay, so if you want to graph this, 0, 15, let's do a little exaggeration. 0, 15, let's say that's 15. And then, what is our slope?
-5.
-5 over 1. So our slope is -5 over 1. So what does that mean we do from 15?
Go to 5. I mean, down 5. You got
Down 5. So what point would this be?
10.
10. But do we plot 10?
No, you gotta go over 1 to the right.
Go to the right one?
Yes. Right.
I'm asking.
Yeah.
Yeah, that's right. And then if you want another one, you do what?
Go down 5.
Drop 5 and over 1. But do we need to plot another point?
No.
No, because all you need is how many points? 2. That's it. What other questions do you have? All right, let's keep it going. So, for each pair of lines, let's determine if the lines are parallel, perpendicular, or neither. For each pair of lines, let's determine if the lines are parallel, perpendicular, or neither. Okay? For the pair of lines I've given you for A, are they parallel, perpendicular, or neither? Neither. Very good. They're neither. So let's talk about why. What's the slope of our first line? 3 over 4. I heard 3 over 4x. I heard 3 over 4. Which is it? 3 over 4, right? The slope is the coefficient of our expression that has x. Okay? So good. It'll come back on. M1 is equal to 3/4. And what is M2? 4 over 3. Good. They're not opposite reciprocals, meaning one is not the negative of the other. So that's why we have here. So we know they're not parallel. So they are not the same slope, which means that M sub 1 is not equal to M sub 2, which means our lines are not parallel. So not parallel. And we also know that these lines are not negative reciprocals. Excuse me. They are not negative reciprocals. Okay, which means they're not what? Good, right? So what we get from this is, as you've already concluded, it's neither. You want a couple minutes to try B? I see heads nodding yes. I'll give you a couple minutes. Feel free to discuss it with your neighbors. Determine if those lines are parallel, perpendicular, or neither. So I'll write it up where you cross multiply so you can see it done differently. Now, as you've already discussed, you said these lines are what? Parallel. Very good. So we know these lines are going to have the same slope. So you can cross multiply here, and you get 6 times 2x minus 3y equals 3 times x minus 1. So you get 12x minus 18y equals 3x minus 3. And then you get negative 18y equals, you add 12x to both sides, so that makes this, or you subtract 12x from both sides to get this is what on this side? Good, negative 9x minus 3. Then we divide both sides by negative 18. That gives us y is equal to negative 9 over negative 18x minus 3 over 18, which is the same thing as 1/2 x minus 1 over. It should be what? Why? Because we're subtracting a negative. Very good. Yeah, that's right. Yeah, talk. Good. So we get our slope is 1/2. And then here, what do we have? For 2y minus x equals 3? Add x, good. To get 2y equals? Good. And then what do we do? Good. To get y equals? Either way, x plus, someone's saying x plus 3 over 2, and which is the same thing as, go ahead.
X over 2.
It's fine.
Yeah, x over 2 plus 3 over 2.
Good. And then you want to write it as?
Yeah.
Good. So identify that both of your slopes, so m sub 1 for the first line is equal to 1/2, and m sub 2, the slope of the second line, is equal to 1/2, so the lines are parallel. Good. Yes. Yes. So the question was, will cross multiplying work for problems like this? Yes. Be careful. The nice thing about this particular set of lines is that in the first part where you have the rational expressions, both of the denominators was a constant. If it's a constant times a variable, it becomes a little bit tricky. So you might want to try another method there. But cross multiplication in this instance definitely works. What other questions do you have? Okay, very good. Part C, you have y equals 5x plus 4 and y equals negative 1/5 x minus 9. Are these lines parallel, perpendicular, or neither? Perpendicular. Perpendicular, very good. Why? Because negative 1 over 5x is the negative reciprocal of 5. So m sub 1 equals 5, m sub 2 equals negative 1/5. There are negative reciprocals. So yes, these lines are perpendicular. What questions do you have? I heard nothing. What questions do you have? Are you good here? That's a question. I need responses. I heard one.
Yes.
Yes? Are we good in the back as well? Okay. All right. So this is section 3.5. This is section 3.5, parallel and perpendicular lines. What you should be doing at this point, you should be preparing for your exam. Okay, you should be preparing for your exam. I will post a review this week for your exam 2, which is also your midterm. Okay, so I will post that. Make sure you're studying. Make sure you're preparing for that. It'll be next Thursday. It will be next Thursday. Okay, again, you know what it's covering. Okay, we discussed this already. So make sure you're preparing. Questions? Yes?
So the quiz that was this past weekend.
Talk loud where everybody can hear you.
The quiz from this past weekend, are we still gonna have that?
That's this week. That's this week. Quiz 2, it's called Quiz 2. The other one I call Quiz 2A. Quiz 2 will be due this week. I will provide an announcement about that. What other questions do you have?
Is that quiz in person?
No. No. What other questions do you have? All right. Okay, that's section 3.5.